Okay, good afternoon. So, electric and magnetism. So, today we will discuss the electric potential. So, imagine that a positive charge Q is released from contact with the Q, let's say we have here, and is allowed to accelerate to an infinite distance away, picking up kinetic energy as it goes. No? So, the change in kinetic energy, so kung maano nyo pa, ma-recall nyo pa sa physics 1 natin, is the work required to bring the test charge from an infinite distance back to Q. So, yung electric potential natin, which is V, is defined as the work per unit charge that is needed to bring the Q here towards the Q mismo. Okay, so V is just a ratio of work per unit charge. Yeah. So the units used in electrical potential or electric potential is joules or that is joules per coulomb, no? Because yung work natin that is unit in joules, and then yung charge natin is in coulomb. So units for the electrical potential is joules per coulomb. So because electric potential is a measure of potential energy per unit charge, so there's a unit of both electric potential and potential difference is joules per coulomb, which is defined as voltage, or that is ginatawag natin siya sa ginatawag natin siya nga EMF or electromotive force. Yan. So voltage or 1 volt is just equivalent to 1 joule per coulomb. So voltage, a variety of phrases are used to describe the potential difference between 2 points. So the most common being voltage arising from the unit of potential. So that is meaning this is just the potential difference. No? So a voltage applied to a device such as a television across a device is the same as the potential difference across the device. So despite popular language, voltage is not something that moves through a device, but instead yung a charge mismo. Yung unit charge mismo yung nag-move. So always take note that the positive to negative kita, positive to negative. So electric potential. What is electric potential at point A of a 2 coulomb? So let's say we have a 2 coulomb of charge that requires 10 joules of work to move from B to A. Okay, so in order to solve this one, so with the use of the voltage formula, it's work divided by the charge. So that is 10 divided by 2. So the electric potential here requires about 5 joules per coulomb, or that is 5 volts. Okay, so that is the electric potential requires 10 joules of work. Okay, so that is 5 joules per coulomb, or that is 5 volts. So the electric potential difference is what we call voltage. So question, is potential energy increasing or decreasing as Q, or let's say 5 coulombs moves towards Q? So is it increasing or decreasing? So how can we know it? Is if the voltage in B, the potential ano natin is 0, and the voltage in A is 10, then therefore no, the voltage is 10 volts at A. So meaning the potential energy is equal to work needed to move Q to A. So that is work that is equal to the product of charge times the voltage, or that is 50 joules. So this is the potential energy that requires, or that is required to work para ma-move siya, ang B natin, pakadto sa A. Yan. So what happens if negative charge naman is moved from A to B? So assume that the voltage in B is 0 and the voltage in naman is 10, so the same. So then as Q moves to A, yung potential energy natin nagdi-decrease. So therefore, our work now is just equivalent to charge times voltage pa rin. So that is the product of charge times the voltage. So that is -5 times 10, or that is -50 joules. -50 joules. And so we have here an example again. No? So this is a battery and a certain plates. So meron tayong 2 plates here. So a battery has a specified potential difference, or this is what we call the delta, the V, or this is the change in potential difference, no, or voltages between its terminals. So we have the terminal A and terminal B, or we have a positive and negative terminal, and it is established the potential difference between conductors attached to the terminals. So a 12-volt battery is connected between 2 parallel plates, as shown here sa figure natin. So the separation between the plates is, let's say, 0.3 centimeter. And we assume the electric field between the plates here to be uniform. Okay, so meron tayong gap. Okay? So we have merong gap tayo. This is what we call separation. So this assumption is reasonable if the plate separation is small relative to the plate dimension. And we do not consider locations near plate edges. So mostly dito tayo sa parang nasa center ng plates. No? So find the magnitude of electric field between the plates. So parang review na lang din to sa inyo. But since introduction is just sa circuits, so related man siya gihapon. No? So for the electric field between the plates, no. So we have here the formula. So that is the change in voltage that is across from A to B. Okay. So meaning that is V sub B minus V sub A. Okay. Or that is equal to 12. Then divided by the distance, or this is just the separation of the 2 plates. So for our example, we have 0.3 centimeter. So we have 0.3 times 10 raised to -2 meters. And the electric field, or the magnitude now of the electric field, is equal to 4 times 10 raised to 3 volt per meter. Ayan. So this is now your magnitude of the electric field in between these plates, 2 plates here. Ayan. So meron tayong electric field. Ayan. So another example. So a unit of energy commonly used in atomic and nuclear physics is the electron volt, or EV, and which is defined as the energy a charge field system either gains or losses when a charge of magnitude E, so that is an electron or a proton, is moved through a potential difference of 1 volt. So that is because 1 volt is equal to 1 joule per coulomb. And the fundamental charge is equal to 1.6 times 10 raised to -19 coulomb. So the electron volt is related to the joule as follows. So meaning, yung equivalent value natin ng 1 electrovolt or electron volt is just equal to 1.6 times 10 raised to -19 coulomb volt. Or that is 1.6 times 10 raised to -19 joules. So take note lang that the electron volt is a unit of energy and not of potential. So the energy of any system may be expressed in electron volt, but this unit is most convenient for describing the emission and absorption of visible light from atoms. The energies of nuclear processes are often expressed in million or mega mega electron volt. Yan. MeV. So, consider two conductors as shown. So, meron tayong positively and negatively charged. So, such a combination of two conductors is what we call capacitor. And so, the conductors are called plates. And if the conductors carry charges of equal magnitude and opposite sign, so a potential difference exists between them. So anong capacitance na tawag natin? So capacitance is capacity. Okay, so it came from the word capacity. So ano yung capacity? So to understand capacitance, so think of a similar notion that uses a similar word. The capacity of a milk carton is the volume of milk it can store. So the same man siya gyapon diri sa capacitance ang capacitor. So meaning that is the equivalent of, or that is the capacity of a capacitor that can be charged. So meron niyang value. So the heat capacity of an object is the amount of energy an object can store. That is per unit of temperature difference. So the capacitance of a capacitor is the amount of charge the capacitor can store per unit of potential difference. So ilang charge ba yung ano niya? Ilang energy ba or ilang unit ba ng potential difference yung store niya? Yan. The capacitance or T of a capacitor is defined as the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between the conductors. So that is C is equal to the charge divided by the change in voltage, or that is your potential difference. So we see that the capacitance has SI units of coulombs per volt. So that is in honor of Michael Faraday. The SI unit of capacitance therefore is what we call the farad. So it came from Michael Faraday. So that's why yung unit natin for capacitor is farad. Or that is 1 farad is equal to 1 coulomb per volt. Okay. So next we have parallel plate capacitors. So ano naman to? So here we have the equation that is C is equals to the permittivity of free space multiplied by the area divided by the distance. Okay, so that is the capacitance of a parallel plate capacitor proportional to the area of its plates and inversely proportional to the plate separation. So here, when the capacitor is connected to the terminals of a battery, so the electron transfers between the plates. So again, that is positive to negative. And the wires so that the plates become charged. Ayan. So saan ba yung charge dito? Dito mismo sa sa area. Okay, ito sa area niyan. So of course, it depends on the dielectric material ginamit mo. Kung anong klaseng plates ba 'yung ginamit mo. And later on we will check what are the types of capacitors, ano yung mga properties niyan. Yan. Okay, so there are 2 or more capacitors often combined in electric circuits. So we can calculate the equivalent capacitance of a certain combination. So we assume that the capacitor is combined are initially uncharged. So meaning hindi pa siya nakakonect sa battery. Okay, or wala pang potential difference na nakastore sa kanya. So in studying electric circuits, so we use a simplified pictorial presentation, what we call circuit diagram. And such a diagram uses circuit symbols to represent various circuit elements. And the circuit symbols are connected by straight lines that represent the wires between the circuit elements. So the circuit symbols for capacitors, batteries, and switches, as well as the color codes. So the symbol for the capacitor reflects the geometry of the most common model for a capacitor, and a pair of parallel plates as well. So the positive terminal of the battery is at the higher potential, and it is represented in the circuit symbol by the longer line. So ito yung natin. Ito yung circuit symbol natin. For capacitor, we have here, ito. And then for the battery, so positive, ito yung may longer line.
Negative naman yung wala. Then we have the switch symbol for the open circuit. Hindi siya contact dito sa kabilang point, while yung closed is in contact. Yan. So ito, meron tayong two types ng capacitor. Meron what we call electrolytic and yung mylar naman. Yung sa mylar, ito yung walang polarity. While yung sa electrolytic, meron tayong polarity. So we will learn that later on. Yan. So how to compute some capacitance? Let's say we have a parallel combinations of two capacitors. Ayan, so pictorial representation of two capacitors connected in parallel to a battery. So meaning ito yung capacitor 1 mo, ito naman yung capacitor 2 mo. And then with the same the same polarity connected to a battery. So ito yung supply mo. Ayan. So circuit diagram showing two capacitors connected in parallel to a battery. So ito na yung circuit diagram mo. So ito yung parang ito yung figure mo or representation, and then ito yung equivalent circuit diagram niya. Okay? But in a parallel combination, it is just the same as ito. Okay? So isang capacitor na lang siya, pero ito na yung total wherein nakaparallel siya. So in parallel combination of capacitors, we just add. Okay? So we just add the value of a capacitor. So that is in parallel combination. In-add lang natin. So how about in series combination? So in series, so this is your representation and your circuit diagram, and this is your simpler or simplest form of circuit diagram. Wherein yung the total capacitance mo in a series is just the inverse. Okay, so that is 1 over C sub 1 plus 1 over C sub 1 and inverse mo siya. So that is your equivalent value of a series capacitor. Okay, in-inverse mo lang siya. Yung dito, ina-add mo lang sa parallel. Pero pag nasa series, i-inverse mo siya. And so this is the equation for this series combination of capacitors. And for example, we have here, no? So find the equivalent. Ito, naka-ano to? Okay. So ito, meron tayong 4 farad. Ito kasi naka-parallel siya. So i-add lang natin to. So this is a representation on how to simplify your circuit into from A, B, C, and D. So from A, combine muna natin to. Ito naka-parallel to. So 1 and 3, so that is 4. And then ito naman, 6 and 2. Okay, so that is 8. Okay. Now therefore, you have now 4 and 4. And then 8 and 8. Diba? So this is in series. Therefore, in series, just get the inverse. So that is 1 over 4 plus 1 over 4. Okay? Or that is 1 over 2 or 1/2 microfarad. Then for this case, baba, the same, 1 over 8 plus 1 over 8 microfarad. Or that is 1 over 4 microfarad. Okay, and now your circuit here is simplified again. So i-add natin to. That is in series sila, di ba? So kung series, naka-ano siya? Naka-inverse, no? That is 2.0. Okay, so 1 over 2.0 or that is 2 kasi i-inverse mo pa siya. And then ito, 1 over 4 or inverse mo siya, that is 4 microfarad. And your simpler circuit is naka-dual na lang, naka-parallel. Dalawang capacitor nakaparallel. So that is 4 and 2. So i-add mo lang na siya. So your capacitance between point A and B is just 6 microfarad. So from this one, from this point, this point, this point, this point, this point, this point. So from 1, 2, 3, 4, 5, 6, 6 capacitors is equivalent to single capacitor na the same ang gihapon ilang nga value. Okay? So yung parang inano lang natin, sinimplify na natin yung circuit niya. Yan. So how capacitor is charged? Yeah. So first we begin with the switch, no? So let's say with the switch open, yung capacitor natin dito is uncharged. Yan. But how about if the switch is closed? And so here, the electrons move from the plate to the wire, okay, leaving the plate positively charged. Okay, so from positive to negative tayo. So now the separation of charges represents the potential energy, or this is also represented by your electric field between plates. Then the electron or the electrons move from the wire to the plate. Okay, and then the electric field in the wire. So this creates a chemical potential energy in the battery, or the chemical potential energy in the battery is reduced, no? And then we have here, so ito na yung equivalent mo na formula. So to compute the charge between plates of a capacitor, so you have your Q squared over 2C, or that is 1/2 of your charge times the potential difference, or you can say that that is 1/2 of charge times the potential difference squared. And so the two capacitors, let's say we have here C1 and C2, wherein yung C1 is greater than C2, are charged the same initial potential difference. The charged capacitors are removed from the battery, and their plates are connected with the opposite polarity as in figure 26.12a. So the switches S1 and S2 are then closed as in figure 26.12b. Ito. Ayan. So what happened if nag-close yung switch dito? And so the switch are closed, the charge are distribute. So before the switch are closed, ito yung potential difference natin, or ito yung equivalent value ng capacitor natin. But after, you will now have your final charge. Okay, so that is the charge of the first capacitor plus the charge of the second capacitor. That is C1 plus C2, and then multiply by the final difference voltage. Yeah. Final potential difference, I mean. So just equate the two equations. So that is QF that is equal to QI. So, or ano ta lang, this is just a manipulation of a formula, that is C1 plus C2, transpose na natin sa biyak para makuha natin ang final differential voltage, or final potential difference, no, of the two capacitors. Ayan. So you have your general formula. Ito. Next, we have to find the total energy stored in the capacitor before and after the switches are closed, and determine the ratio of the final energy to the initial energy. So i-compare natin yung final energy to the initial energy. So we have here the formula that is from the initial, and for the final we have here ito. Okay, so this is just the ratio. Okay, so this is just the ratio. So cancel out lang yung mga common formula. Then matitira dito is ito. Ayan. So that is C1 minus C2 divided by C1 plus C2 squared. Or that is your ratio of the final energy divided by the initial energy. Ayan. Okay, let's move on to the dielectrics. Ano yung dielectrics na tinatawag? So, electric material, so such as rubber, glass, or wax paper. Okay, so we have here the formula. That is C is equals to K multiplied by the C sub 0. And so dito sa figure natin, so from figure A, the potential difference across the charge capacitor is initially 0. Or this is just your potential difference mo. Okay, 0 in potential difference. But with the electric in place, okay, so the charge remains the same, but the potential difference decreases. So, anong nangyari dito? So, yung potential difference decrease, but the capacitance increases. Okay, so this is with the use of the dielectric material. So we have here various materials at room temperature. So the dielectric concept here, so we have here different materials. So let's say air. This is dry air. So we have here 1.00059. So this is your K constant for the dry air. For the bakelite, we have 4.9. For the fused quartz, we have 3.78. For the mylar, we have 3.2 and so on. So yung water natin, that is 80. Yan. And yung strontium titanate naman natin is 233. Okay. So take note of this table. No? So these are just approximate the electric constants and their the electric strengths. Yan. So this is in terms of volt per meter. Okay. So physical capacitors have a specification called a variety of names. So including working voltage, breakdown voltage, and rated voltage. So this parameter represents the largest voltage that can be applied to the capacitor without exceeding the dielectric constant or the dielectric strength of the dielectric material in the capacitor. So meaning ito lang yung maximum na capacity niya na ma-handle. So pag nag-reach na siya, it might bust your component. Basta maglapok ang capacitor or something if that exploded, no? Basta masunog pa. Yan. So consequently, when selecting a capacitor for a given application, so you must consider its capacitance as well as the expected voltage across the capacitor in the circuit. So making sure that the expected voltage is smaller than the rated voltage of the capacitor. Okay. So therefore, a dielectric provides the following advantages. So an increase in capacitance, an increase in maximum operating voltage, and possible mechanical support between the plates, which allows the plates to be close together without touching, so thereby decreasing the distance and increasing the capacitance or decreasing the what you call this, the electric constant, no? Or yung distance mismo within the plates, and yung charge natin is increases. Yan. So we have here types of capacitors. And so many capacitors are built in integrated circuit chips, but some electrical devices still use standalone capacitor. Commercial capacitors are often made from metallic foil interlaced with thin sheets of either paraffin impregnated paper or mylar as the electric material. So these alternate layers of metallic foil and the electric are rolled into a cylinder to form a small package. So high voltage capacitors commonly consisted of a number of interwoven metallic plates immersed in a silicon oil. Thus, capacitors are often constructed from ceramic material. Yan. So mostly sa mga ceramic siya. So a tubular capacitor, ito, whose plates are separated by paper and then rolled into a cylinder. And so ito yung high voltage capacitor which consists of many parallel plates. Ito yung plates niya, parallel. And it's separated by insulating oil. Okay, so ito yung silicone oil natin. Or we can have this metallic foil plus the oxide layer. So this is a electrolytic capacitor. No? Yan. So electrolyte natin sa loob. Then meron siyang metallic case sa labas. Then meron tayong contacts. So ito yung example ng Mylar capacitor. Yan. So often an electrolytic capacitor is used to store large amount of charge at relatively low voltages. So ito yung Mylar, ito yung walang polarity. Yan. Itong electrolytic capacitor, ito yung may polarity. So this device consists of metallic foil in contact with an electrolyte, a solution that conducts electricity by virtue of the motion of ions contained in the solution. So when a voltage is applied between the coil and the electrolyte, so a thin layer of metal oxide, or this is what we call our insulator, is formed on the foil, and this layer serves as the dielectric. Okay. So very large values of capacitance can be obtained in electrolytic capacitor because the dielectric layer is very thin, and therefore the plate separation is very small. So ito naman yung example ng electrolytic material or electrolytic capacitor. So they are not reversible as many capacitor, and they have polarity, which is indicated by a positive and the negative signs on the device. So when it gets otherwise, the applied voltage is the opposite of what is, and the oxide layer is removed, and the capacitor conducts electricity instead of storing charge. So we have here, no? Ito na yung ginagamit natin ngayon. This is a SMD type of capacitor or surface mounted capacitors. Makikita to siguro sa mga cellphones, no? Mga SMD devices natin or SMD nga components natin. Ayan. Ito makikita mo lang to sa mga old radio, old TV. Yan. Ito, makikita mo to. Still widely used pa rin naman. Yan. Ito yung Mylar, no? Ito yung Mylar. So variable capacitors, ito yung isa pa sa mga example wherein ginagamit to into tuning, no? Tuning of frequencies. Mainly gumagamit ito yung mga radio. Okay, so this is typically from 10 to 500 picofarad. So one so depende. So this and so sum up our discussion for today, no? So you may these 3 YouTube links for information and details. So that's it for today. For today.